Hey everyone, NET-200. Alright, we're in week 12, and this is Friday, and the date is the 18th. Okay, so what we talked about, we are trying to get a clear understanding of IP addressing. And we're going to focus on IP4 and then be able to transfer that to IP version 6. Alright. So here, the other day in IT Essentials, we talked about my workstation in front of the room was on the 172.31 network. Now, how do I know that that's the network part of this address? How do I know that? Because of this /16. If we were to look at the mask on the computer, it'd be 255, 0, 0. 8, add those together, that gives us our 16 prefix bits. Alright, and then the students for the other class, they all had these 20 addresses, but what part of that's the network? It's a /16, so I got 8 and 8, so that's this part is the network part. And that's what a router is going to use to move from one network to another. It's going to use the network part of the address, and it will ignore the other part based on the mask or prefix bits, which will be more as time goes on. Next thing, then we took a look at a network. We've got a router here, connect it with a WAN, LAN, and a LAN. And so the first thing we did was count the networks. 1, 2, 3, 4. There's 4 networks. Okay? 4 networks. So there's 4, like there's going to be an interface here that will indicate that network, be an address on that network. 1 here, 1 here, 1 here, and 1 here. Okay, so then I made up an address to use. We're going to take this address and we're going to subnet it. And so /24, 888. So this part we're not going to change. That's going to stay the same. So we're going to use these 8 bits to subnet, like right here. These 8 bits to subnet. So since we need 4 networks, okay, what we did at first was we looked. How many bits do we need to borrow? So we got 24, so we're going to borrow some more. We can borrow 1 and make that 25, but that would only give us 2 networks. 1 would only give us 2, so that's not going to work. So we borrowed 2 bits over to here, /26, and that's what we used. And that gave us these 4 networks. These options right in here. 0, 0, 0, 1, 1, 0, 1, 1. This is 0, 0, 0, 1, 1, 0, 1, 1. And you get those use of these numbers up here, right? This goes back to our initial use of bits and being able to convert them one way or another to binary or decimal or hexadecimal, which we'll talk more about as we go along. Alright, so then here's what we did. I went up here and I said, okay, what if this network needs 62, this network needs 14, and this network needs 30? So we said, will this combination work? And it will. Okay, so we took this address right here, /26, that has these bits here available to the 6, 64 minus 2 for the network and the broadcast, that gives us 62. So we can use that up here. And so here's that addressing for that network. We figured out the mask. If there's a 1, for the 26, so if you have 8, 8, 8, and then 2 more, 24, 25, 26, those two together come out to be a 192. Okay? And then we figured out the addresses. Can't use 0, because that's the network. We can't use all 1s. That would be 63 here at the end. So we go from 1 to 62. And then you'll notice the next jump over here, 64. All right. Then here's the important part. Then we said we only need 30 here, so we want to be conservative. So we took this address with the 64. Again, these would be the same. And since it's a /26, these two would be the same. And then we use this one to make the new network. So it went from 26 to 27 prefix bits. So here's one of our networks, 64, right here. And then this one is this one. We'd add a 16 on. Or actually, excuse me, it'd be a 32. We'd add a 32 on. 32 on the 64 gives us 96, and that's our other network. So what I did in class, we took this one, this new subnetted network, which, based on this, that gives us 30 addresses, 2 to the 5th, 32, got to subtract 2 for the broadcast and the network, and that gives us 30. So we assigned it here. And we figured out the mask. The mask would be, since it's 27, so it's 24, 25, 26, 27, those would all be 1. So we took 128 plus 64 plus 32, got 224. And we assigned it. And now we still have left an address with the possibility of another 30 that we could use somewhere else. All right. Then to finish up, we did this 14 over here. I'm going to do that. So I took the next address, I took actually the last address on the other side, /26, and said, let's divide that one up. So I took one of those, so that one's there, and then I said we're going to borrow 2 more bits, because then this 2 to the 4th, which is 16 minus 2 will give us our 14 addresses. Okay? So that'll give us 14 addresses. And here then, 2 more bits. This was 26. 2 more, so now it's 28. And we have 4 combinations. So we did the first one, 128. That would be this. Then we took 128 plus 16, 144. And then 128 plus a 32, 160. And then 128 plus 32 and 16, 176. And then you could use one of those for that network that needs 14 addresses. And then we still have these left. And then to finish up, we didn't go all the way through it. I said, well, we could take another one of the addresses we haven't used yet, 192, and that's this one, slash 26, right? 24, 25, 26. And then, if we're going to connect the WAN connection, in which we only need 2 addresses, we can go like this. This would give us 2 addresses. 2 to the second is 4, minus 2 is 2. And then, right in here, we have these that we could use. So we can make quite a few 2 addresses, right? We can make 16. Or you can actually figure out how you might divide that up otherwise. Alright, and so I put the solutions to the 2 labs for Chapter 8. Okay, so Chapter 8. We took the exam for the first time. And then students can take that again next week. And we're going to start Chapter 9. Actually, we'll go through most of that next week. That's it.